Hello and welcome to today's Tech Talk on AI, ML plus mathematical optimization, overview of benefits, case studies, and pro tips. My name is Haley. I'm part of the Next Move team, and I'll be your MC for today. Our presenters are Carolyn Mooney, CEO of Next Move, and Yash Puranik, Director of Decision Sciences at Aimpoint Digital. They'll be hosting a conversation that covers an overview of optimization, the collaboration required to get optimization projects live, and some starter steps. We're saving time for Q&A at the end, so we encourage you to use the Q&A feature at the bottom of your screen. You can also use the chat off to the side. Just keep an eye on that host and panelists versus everyone toggle so your question or comment goes to the right audience. And with that, I'm going to disappear into the Zoom backstage. Carolyn and Yash, take it away.
Awesome. Thanks, Haley. And Yash, super excited to have you today to talk about all things optimization. I know you work across a wide variety of industries and use cases, so it should be a really fun conversation. Do you want to go ahead and give yourself a brief introduction?
Yeah, thanks for inviting me, and I'm looking forward to this chat as well. Always enjoy our conversations. My background is I come with a PhD from Carnegie Mellon. I spent most of my time researching mixed integer nonlinear programming algorithms, and I've spent the last 15 years working on different algorithm development, solver development, and practical applications. So very excited to be here, and also want to give a huge shout out to Haley, Dawn, and Renu, who have done tremendous amount of work behind the scenes to set us up for success. So let's hope we don't
Nice.
fail.
Well, we'll start out with an easy question first. So, we've been talking a lot about how AI fits into businesses, right? And a lot of different technologies go into that AI bucket. So, we're really trying to focus on mathematical optimization today. Maybe you can give a brief background on what mathematical optimization is.
Yeah, and it's funny because sometimes I think it's just easier to start with what is not mathematical optimization. And I think that's a part of our problem with branding. The word optimization is overloaded in many contexts, and we also rely on the same word. So just to clarify, with mathematical optimization, we are not talking about search engine optimization. We are not talking about LLM optimization. We are not talking about business process optimization or database optimization or any of the myriad contexts you might have heard the word optimization in. The main specific thing we're talking about when we say optimization is we're looking for tools, models, techniques that help you make better decisions. And that's just the part I want to reemphasize. We will probably come back to it more than once in today's Tech Talk. And the key part of mathematical optimization is when you're faced with situations where you have certain decisions to make, your decisions are limited by physical realities or business rules or any other things, and you have to evaluate a number of trade-offs before deciding the best course of action. The models and tools that help us solve this problem is what I'm referring to as mathematical optimization. It's known by different names in many communities. You could refer to it as math programming, operations research, decision science, and so on and so forth. Curious to hear your take, Carolyn. What do you think is mathematical optimization for you?
Yeah, I think about a lot about I like the like trade-off like kind of terminology, right? So you're trying to figure out kind of what the best decision is based on a lot of trade-offs, right? And so a lot of these problems, right, if we were to sit down and solve them on a small scale, right, like a scheduling problem or a routing problem or pricing problem, we would be able to do so. But when you kind of blow it up to the scale of larger enterprises, things like that, right, it just becomes very complex. And so they can be anything from like business rules like driven and all the way up to like more complex constraints or involving things like predictive models. And I think that's kind of the space that I think about is like sequencing sequencing tasks for people or machines, right, or assigning tasks to people or machines, right, making those decisions for the business. So you touched on a little bit of like kind of like where it's used, but maybe let's get like really practical about some use cases. So what are some common use cases you see at Aimpoint as you're working kind of across different businesses, and what are some exciting ones that you're seeing kind of in the field?
Yeah, the fun part about optimization, I think, is once you start learning how to recognize mathematical optimization use cases, they exist pretty much everywhere. They exist in multiple industries, and we listed a few examples out here in manufacturing and energy and even government, for example, but the possibilities are endless. And I think the other interesting thing to also keep in mind is that these applications exist across many verticals. So it could be, or horizontals. Anyway, I'm forgetting what the right term is, but they exist in a lot of different functions as well. It could be in finance, it could be in logistics, it could be in supply chain. So possibilities are endless. I think some of the more fun ones that maybe we might have heard of or don't always think about is, as an example, the NFL scheduling, right? That's a very classic optimization problem. Just trying to decide which team plays against which team and when. And you have to account for a lot of different things. You have to account for travel times. You have to account for did team A just play 5 home games in a stretch? Do they need to have an away game next? What are the TV schedules and TV rights look like? So a very, very classical optimization problem. There's a webinar on YouTube on how it's solved with optimization. I'm sure many of us have heard the story of how UPS trucks never turn left to try and minimize their travel times. That's just a small part of the big solution. And the snip we have here is from the Informs website, and even back then it talked about how the project and the pilot scale itself had saved hundreds of millions of dollars to UPS. So you can only imagine what the savings are once it was deployed on the full scale. Uh, yeah, I think as far as I think the applications are just endless. What do you think, Kevin? What's some examples you see most often?
Yeah, I mean, I've definitely you hear a lot about obviously like multi-vehicle routing. Like routing, I feel like traveling salesman or traveling salesperson problem, right, is the one that most people think of when they think of optimization. And so I think it's like good to highlight that it really isn't just routing, right? It's workforce scheduling, it's setting prices, it's even honestly like most grocers are optimizing where certain products are on the shelves, right? So it optimization really does have a high amount of impact on our daily lives. I think it's just sometimes a little hard to see, right, or not as obvious. And I'm really excited about how optimization can play a role in sustainability. I think that's a big one. Even in the routing, sphere, right, reducing time on road or reducing fuel usage, right, is great. But there's also a lot of applications in like how you select between different energy resources, right, or how you optimize energy to different parts of the grid, that sort of thing. And so there's a lot going on in the optimization ecosystem. And you mentioned before, right? UPS or these companies, right? They could be saving millions, if not billions of dollars a year using these systems. And that's because these small decisions on the everyday plans that they're making or the real-time plans that they're making, right, can have outsized impacts when you roll them up. So I guess that leads me to my next question, which is why haven't we heard much about it, right? Why is the mathematical optimization
Yeah.
more popular? Why aren't more people talking about it?
Yeah, and actually, just going back to the previous point that you're talking about in the use cases, I think another important thing to note is we often think of the tactical or the real-time decisions that we're trying to make that we can solve with optimization, whether that's vehicle routing or food delivery or what have you. I think the other thing to remember is optimization is also heavily used in strategic decision making. So, for example, if you're trying to figure out where to drill oil wells
Yep.
and trying to decide what might be the best way to increase production. And yeah, these are decisions that are made on a very long time horizon. And they're
Yeah.
also decisions that have a lot of uncertainty, but they can also drive a lot of impact with optimization. So,
Or where to build a new facility, right? Or something like that
right.
for your organization. Yeah, for sure.
Right. So coming back to why we haven't heard as much about optimization, and I hope that's not true for this audience, but maybe it is. I'm just sharing my perspectives on it. Curious to hear if the audience has any thoughts. Feel free to put in the chat, and we can learn more from each other. But I think the main thing we've been waiting for is we've just been waiting for compute power to catch up. We knew how to solve these problems as a community. Many of these algorithms have been developed as early as World War II, and they we just didn't have fast enough computers, and we just didn't have enough good implementations. I think the other part is I think we are slightly hampered by the textbook understanding of the fact that many mathematical optimization algorithms are NP hard and they don't scale. And that might also be true of many business managers who are now in positions of leadership, but who learned about some of these techniques 20, 30 years ago when we did not have efficient implementations. So it just feels like the community as a whole does not recognize that you can solve many practical problems efficiently, even if they are NP hard, and even if you don't always have guarantees of global optimality, what have you. I think the last piece that I find most interesting about optimization is that the solutions are often counterintuitive. And if you're used to doing things a certain way, and if you're used to running your operations in a very specific way, and if your optimization model now suddenly suggests you do something different, uh, that just raises a lot of questions. And I think that just requires a lot of work to actually build trust in the solution that we don't always put in as a community. That's just my take. What do you think, Carolyn? What are we missing?
Yeah, I think the compute resources definitely part of it, right? When I worked at Lockheed Martin, kind of my first job out of school, and we had our own, server stacks to be running like simulation and optimization work, and that was because we needed really like high power machines. And I think now with, all these cloud services kind of having infrastructure kind of at your beck and call to a certain degree, it makes it a lot easier to apply these different technologies. And I think there's a combo effect of a lot of the solvers in the space, right, have gotten a lot faster and a lot more compute efficient as well, right? So the combination of those two things, I think, has made it a lot more possible to use optimization in those like tactical and real time scenarios. And I think that's why we're starting to see like a proliferation of more use cases for optimization because I feel like once you start thinking about things as mathematical optimization problems, you can't stop thinking about them, right, as mathematical optimization problems. So I think you had an example once that I remember you saying about the ozone layer, right, and like kind of
Hmm.
like thinking about like the mathematical optimization problem for an alternate, right, to was it Freon?
Freon, yep. Freon
Yeah.
was destroying the ozone layer, and when we're trying to find a molecule that does exactly everything right that Freon does as a refrigerant and just doesn't react with the ozone layer, that's a fun problem that you can solve with mathematical optimization.
Yeah.
So I find that very
Yeah, so I
interesting.
think part of it I think is just like the compute power catching up, and then I think part of it is really just a knowledge of what types of use cases can be solved with this technology, right? There's a lot of different AI technologies, and so knowing kind of where to apply each of them, and for what use case they shine, right, is I think is a really good way to think about it. I know we have some questions about technologies in the chat, so we'll definitely get to them at the end there.
Yeah.
So maybe switching gears a little bit here, how do optimization projects happen? You guys at Aimpoint are helping a lot of different organizations build, more efficient decisions into their operations, right, and into their services, right? So how do you think about the process of getting an optimization project live?
I think we definitely have a standard process that we typically follow, and we don't have enough time to get into all the details. But just at a very high level, I think some of the steps here should seem very logical for everyone here, right? We spend a lot of time is with the discovery phase and the problem framing phase. There are, of course, iterations when you do model development, you test it out, you share results with stakeholders. They say, oh, this looks good. Oh, this does not look good at all. We would never do X, Y, Z because of this. And we're like, well, you never told us about this constraint. Let us go back and put it in and let's rerun the model. So those kinds of cycles, I think we all go through on every project, not just optimization project. I think the part that we spend a lot of time on, I think, is specifically the stakeholder buy-in part, where I was reading on LinkedIn the other day, and I forget who posted it, but they posted something about it's easy to disagree with predictions. You can just write them off as a bad prediction, but people will disagree with decisions they don't like, and that makes sense because if we're explicitly recommending a course of action, we need to be able to justify it and stand behind it. And I think that's the part where as a community, we could definitely invest more time and spend a lot of effort in trying to make sure the solution is valid and captures everything that stakeholders need. I think there's, of course, the phase of performance optimization and specifically around deployment. And I'm sure, Carolyn, you have a lot more thoughts around deployment and maintenance. Maybe I'll let you chime in. What do you think are some of the important aspects around deployment and
Yeah, I think one of the interesting things is decision science gets a little closer to software, right? And it's not to say that data science is not, right? I mean, like there's a lot that goes into like ML engineering these days, right? And ML ops tooling. But I think a lot of the data science space, right, has like come to understand that their models need to operate in software stacks. And I think for decision models, because a lot of our decision models have been strategic, right? Historically, because that compute time like wasn't good enough to make a tactical or a real-time decision, right? I think there's a little bit less focus on the software engineering aspects within the optimization space. And so a lot of that is what builds trust within the organization, right? You kind of have multiple parties that kind of care about optimization. I always kind of say it's a multiplayer sport, right? Between your software engineering team, your operators, right, or your business side, and also your modelers. I also think there was something interesting that you said to me probably a couple of months ago that I really liked, which was the difference between like the data science world and the decision science world is in data science, you're really using your focus is on the data. You're trying to collect like a lot of data and representative data and then utilize a variety of different algorithms, right, or models for making those predictions, whether it be um, any type of like regression model or anything it might be, right? And in our world, you're actually trying to build the model itself, right? You're trying to like build the mathematical representation of the business problem that you're solving. And so I think that's also a little bit of the difference, and I think it's kind of interesting. And the last thing I would say is business criticalness of of these models, right? When you're making decisions that impact a plan for the operation that say whether a driver is going to a particular stop today or whether a person is working next week, those are really, really important and business critical systems. So if forecasts go down, like you can kind of still operate. It's not ideal for sure, but your systems can still kind of move. With the decision space, right? Your operation can sometimes grind to a halt, right? So it's really important to kind of get some of the software pieces right here.
Yeah. I guess I was just going to say that's one more point where we sometimes lead to confusion with terminology. The word model is overloaded. When we
It's
think of a
true.
machine learning model, we think of the classical train, predict kind of operations. With an optimization model, there is no train. So
Yeah,
it also makes things a little confusing.
for sure, for sure. Awesome. Yeah. And I was mentioning, the way I think about this as like a multiplayer sport, and maybe this is a good way to highlight it, right? When you think about like the three teams that are involved in like making decisions and within your automation, right? There's basically the engineering team, which is focusing on integrating these decisions, right, or models as services, right? They're focused on like the API layer, making them scalable, making sure they can run, they're not failing out, right? Observability, that sort of thing. The modeling team, right? That's what kind of what we're focusing on today. But that's where those are the people that are actually building the models, right? They're working with the business side. They're saying these are the things that we care about. This is what we want to optimize for. This is the KPI we want to minimize or maximize. And their focus really is on like building those models, and they get distracted by kind of all the tooling and infrastructure things that have to happen. And then finally, there's like the operations side, which is leveraging these models to make a difference in their business, right? The UPS, right, getting millions of dollars of benefit, right, for their optimization models, right? That's the thing that they want, right? Or they want to automate decisions or augment decisions, right, for their operation. And so it can be distracting sometimes when they're trying to decipher results, right? Or they don't understand kind of how decisions are going to be made, or they don't have intuition basically about like what the decision model is going to do. And I think getting these teams to smoothly work together is crucial, right, to getting these systems live and get building trust like over time in the automation or even the augmented systems that people have.
Yeah. That's yeah, and just to complement that, I think that's been a very important growth journey for me since leaving grad school. I think back in grad school for me, the most difficult part was building the model, and once the model was mathematically correct, I thought I was done. I didn't need to do anything else. Now I think after a few small years of experience, I think the main thing that I find satisfaction is if the models I've developed are they deployed in practice or not. And
Yep.
you actually have a solution being utilized in practice does require a lot of players, like you were calling out. It's a multi-team sport. A lot of things have to go right, and a lot of people have to do their job right to make it into
Yeah.
production. So that's where some of the real fun is now, I think.
Yeah. I mean, I think Ryan on our my CTO and our co-founder always says like, if something's not live in production, right, it's a cost to the business. And so, it's really, really important to get these decision models, right, and predictions, right, any type of AI, model live, right? That's the key because like until it is, it's not providing value, right, to the business as a whole. So maybe if we think about it from the business side now, like what should business leaders be asking of their decision scientists, data scientists that are starting to build models with mathematical optimization or other technologies, any AI technology?
I think my biggest pet peeve, especially over the last couple of years, is how sometimes we put the cart before the horse, and sometimes we get asked, "Can you help us implement Gen AI in our supply chain?" And I think the key focus should always be what are you trying to solve and what are you trying to achieve, and then maybe have faith in the technical leaders you have on your team to figure out the right method. So maybe the question should be, let's optimize inventory and find a way to reduce working capital costs instead of explicitly using Gen AI for something. I think the other thing I would ask the decision modelers is to be more, oh, sorry, the business leaders is to be more direct. I think there is value in them learning a little more about some of these methods, but also there's a value in them just asking a lot of questions and not letting us scare them with silly jargon and terminology. So I think things around reporting, visualization, transparency, testing, I think those are two-way streets. I think the business leaders should
Yep.
feel more and more empowered to ask more questions, and it is our responsibility to deliver those answers to them. Uh, I think we have a couple of things listed out here. You have more experience with rollout strategies, so maybe you can take those on. What do you think we should think about in terms of rollout strategy and so on?
Yeah, I think from the business side, one thing that I see occasionally is just a desire to represent everything at once, right? So I can say to a lot of leaders, you already have a decision service today. It is in the brain of your operator who's making these decisions
Mhm.
today. So like what the software is trying to do and what the modeler is trying to do is trying to extract that stuff and make it, more predictable what's going to happen on any given data set and a higher amount of accountability, right? You can go back and look at the decisions that were made and understand why they were made. And so I think part of what I see, like, what I see as an ask is ability to be iterative, right? So like starting simple and not necessarily capturing everything about the decision from the get-go, I think is a really important thing. And I also think that is crucial for building trust in the solution. So if you start really simple and you only represent kind of the base layer rules in the decision in that model, I think that's a great way to start because then you can have a lot better intuition about a simple model than you can about a really complex one. And so like if you start to build trust that way and maybe it only covers 80% of the cases and your team is still manually working on 20%, I think that's okay, right? I think we should be
Mhm.
able to like crawl, walk, run these systems and not everybody's going to like start out like Uber that assigns drivers every minute on the minute, right? As you guys, as like more riders, right, are trying to book rides, right? So I think like jumping to that state isn't reality, right? You kind of got to increment your way there, and along the way, you're going to save your team and a lot of time and be able to scale further, right? And so like that's kind of the goal, right? Is like, save your operators a lot of time, give them better decisions to work with as a base layer, and they can always make modifications on top. Like I don't think it's realistic to think that any automated system is going to be 100% accurate all the time. Then we would have like an Oracle, and it would be awesome. um, so maybe we've had a couple questions in the chat about LLMs, mathematical optimization, traditional machine learning, right? Like, what are some of the differences, or like, why not just use ML for some of these decisions that we've been talking about, like scheduling and routing, et cetera?
Right. So that's a good question, and to be honest, I think some of the distinctions I'm going to draw here are just based on my experience. But I do think for any practical solution, you are likely going to need elements of one or more of these techniques. So I don't think they're as separate as sometimes they're talked
Agreed.
about. But yeah, I mean, at the end of the day, I think that's the main part, based on our earlier point too. I think the focus should be in building a holistic solution. And I think optimization is a great tool for many of those problems. It's not the only tool, and it's likely not going to be something that works in every situation. But I think the key thing for me, or the key differences with typical machine learning models, the goal is inference or is insights or it's prediction. Whereas with optimization, the goal is recommending decisions, courses of action to take. And from that perspective, we briefly touched before the word model is overloaded. With machine learning, you're trying to fit patterns based on data. You're trying to take a bunch of data and try to fit it into maybe say a decision tree kind of model and see what best parameters you get. With optimization, we're trying to explicitly model the physical relationships that we want to cover, which makes it very interesting, also sometimes a little challenging. Uh, I think the other thing I just want to maybe sheepishly call out is all machine learning models are solving optimization problems in the back end. You're all trying to minimize error between the actuals and the predictions on a training set, and guess what? That's an optimization problem. So they exist everywhere. The
Yeah.
data requirements generally tend to be different for optimization. I think for machine learning models, we typically say more data is better. With optimization, we just need very specific data, and sometimes that's a lot less than what you would need for a machine learning model. The compute and the parallelization things are also slightly different. So maybe we'll skip some of those technical details. But yeah, I think the key thing to
Yeah.
remember is always with optimization, the key point is you're trying to explicitly make decisions. With machine learning, that may not always be the goal. Of course, you could say that I take in the 100 years worth of decisions that maybe my organization has made, assume each one of them was the best, and become up with a predictive system to recommend the next best decision. That's possible, not always recommended, but as far as
Yeah.
optimization is concerned, the focus is always decisions. What do you
Yeah, I
think?
think one of our advisors at one point said, Carl Hoffman, who's obviously super experienced in the optimization space, she was mentioning that like a lot of machine learning is kind of thinking about looking backwards, or looking backwards at your history of data, right? And kind of saying like what is the most likely thing to happen based on that history, whereas optimization can handle kind of looking forward, right? Where it can say apply this logic on any data set that I get going forward, regardless of its structure, right? And so you may see things in your business, right, that didn't happen before. I think COVID's a great example,
Mhm.
right, or any of the supply chain disruption things. And so your system should be resilient to those changes by just like saying what's important to you, right, in these decision models. So we kind of had the question too about why not LLMs, right, or Gen AI. I maybe I'll kind of put my comment in here first before you, but I think one of the things that I see with LLMs is they're very, very good at allowing you to have a natural language conversation with data or with a system, right? They are not necessarily super efficient at what I would say optimization does, which is kind of like a fancy search, right, through all of the possibilities of your decisions and getting you the best one, right, based on your criteria, right? And so the predictability aspect, I think, of in a mathematical optimization model is super important, and then also just stylistically, like you want it to be very efficient in that search, right? And that's not necessarily like how an LLM is always structured in that way. And anything you have to add to that, Yash?
No, I agree with that completely. And I think just want to be careful about terminology too. I think we were careful to use the word Gen AI here, and we are not saying AI. I think the word AI is sometimes now commonly used to mean Gen
Very
AI too.
overloaded.
There are arguments on should you consider optimization as AI as well. And I'm not going to get into those semantic arguments. I think the main thing is just making sure you're using the right thing for the right problem. And whether you
Yep.
call it AI or something else altogether,
Yeah.
it's beyond me.
No, I agree. I like this framing too, right? It's like, data analytics, right, is like the what is happening. A lot of the machine learning aspects, right, and data science aspects are what might happen. When we start to get into decision science, is what do I do about it, right? And a lot of like the LLMs and Gen AI is like, what does it mean, right? Or can you explain parts of it to me, or can you like talk to me about that data?
Yeah.
So, as a kind of some final thoughts here, what are some ways for people to get started? We have some folks here that are in, data science and are looking to get into maybe decision science, like for their business, right? Or some business leaders. Like, how do you know if you need optimization? Kind of what are the key things to look out for?
I think some of the key, I mean, we've listed some of the key signs here, but I think the main thing to think about is, am I trying to make a lot of decisions or am I trying to build a system to replace a lot of decisions that are being made manually? And are there too many choices to consider that there's a good chance the manual decision making is not capturing the holistic nature of the system? Those are I think, the two key things to think about in my mind. I think things like how frequently the decisions have to be made and how consistent they have to be, and are they really
Yep.
based on somebody's tribal knowledge or something else? I think those are all things to consider. One fun thing I always see is if there's a person who's just fighting with a lot of Excel sheets all the time to come up with a decision in their role, worth thinking if you could replace that with optimization.
I think I think that is a definitely a symptom, right, to look out for. That you might have a decision, service or model on your hands, right? Is if you have like very complex spreadsheet logic, to combine a bunch of different data sets into a decision. I think that's definitely a good one. I know we have a few different resources here. Definitely interested in the chat if anyone has any others that they would point to. But there's a variety of different resources. We'll send these out after the webinar as well. But if you're looking for conferences, happy hours, etc., Informs is a great place to start. There's various different webinars. There's also, some newer resources popping up like Optimization for All. We're super happy that the space has been growing, and there's a lot of stuff going on in our ecosystem right now, which is very exciting. And so, happy to hear if folks have, more suggestions. But with that, I know we're almost right at time, so we'll probably switch over to a quick Q&A and then we'll close out.
Thanks, Carolyn. Thanks, Yash. There's two questions that I'm going to look to surface, and one of them actually just relates to what you were just covering, Carolyn, around someone was asking where can they go, or where would the two of you suggest someone goes to kind of get started in terms of working with like real world problems in the OR mathematical optimization space? Does anything come to mind? We can certainly send some resources afterwards as well.
Yeah.
Go ahead, Yash.
Yeah, I think some of the references listed here are very useful. There are some online classes from Stanford and other universities that are free to access that give you a good basis in how do you start writing some optimization models and algorithms. I don't think we have a single resource like Kaggle, for example, that although there are some optimization challenges on Kaggle, so those could be worth starting looking at too. But hopefully that changes with resources such as optimization for all coming up. Yeah, we'll be sure
Yeah.
to think of more resources and send them later as well. Carolyn, do you have any answers to you?
No, I think that's a good call, and a lot of the solvers in the space, especially like the open source ones, do have a fair number of examples. I think that's maybe a good place to get started too. Whether you look at OR tools or highs, or even some of the modeling layers like Pyomo or Pulp, right? They do have some examples that at least you can get familiar with kind of the structure of problems and how you can solve them with optimization. So I think that's a pretty good starting spot too. We'll send them along for sure.
All right, excellent. And I'm not sure that this got covered. I know there's a lot of discussion around LLMs and Gen AI. Someone was musing out loud around possible applications between graph neural networks and mathematical optimization. Any thoughts there?
I, I think to an extent it depends on the problem. So this is where I'm going to try and use the NP hardness that we mentioned earlier, not as a crutch, but as a meaningful explanation of things. Given that many of these problem instances are NP hard, there cannot be a single efficient algorithm for all. We know branch and bound and some of these other methods work efficiently for many in practice, and I could totally see graph neural networks helping speed up some algorithms or some applications. It may not be for all. So I think it might be worth just thinking a little more about which applications you think specifically could benefit more from graph neural networks. But in practice, I think a lot of optimization algorithms, solvers can often be thought of as a bag of tricks. Some people don't like that terminology, but we just, at the end of the day, there is no magic bullet. So we're all trying a lot of different things to speed up our search. So graph neural networks can be just as good as a tool as, say, the feasibility pump or
Yeah.
techniques.
Yeah, I was gonna say too, there's a lot of combining these technologies these days too, right? So if you can get to like a reasonable potential solution and you feed that into an optimizer, you can kind of like warm start, right? Or feed it into a solver, I should say. You can kind of warm start those solutions too. So like that's also something to think about. Ways that you can kind of connect the two. And we have some other talks that we've done on kind of connecting ML and OR as well.
All right, excellent. I think I'm gonna stop us here. I know that we've run a couple minutes over. We really appreciate everybody hanging out with us for the extra time here. If we didn't get to a question or if you have follow-up questions, we'll be in touch after this tech talk. The recording will be shared with everyone shortly. Carolyn, Yash, thank you so much for your time today. Until next time.
Thanks.
So, bye for now.